Step 1 is excitation. Action potential moves along the neuron to the axon terminal. It reaches the voltage-gated calcium channels, which opens them and allows calcium to enter the cytoplasm. The calcium binds to the synaptic vesicles and pushes them down and triggers them to release the acetylcholine. The acetylcholine crosses the synaptic cleft to bind to the ligand-gated sodium channels on the sarcolemma.
Step 2, excitation, contraction, coupling. The acetylcholine is a ligand which opens the ligand-gated sodium channels, which allows sodium to enter and go into the T tubules. This causes the voltage-gated calcium channels in the sarcoplasmic reticulum to open, which then lets the calcium leave the overpositive area due to the sodium in the T tubules. The calcium binds to the troponin. Step 3, contraction. When calcium binds to the troponin, it causes the tropomyosin to shift, exposing the myosin binding sites on the actin. The myosin heads then bind to the actin and change shape to walk along the actin, which shortens the sarcomere as the myosin and actin overlap. This motion is acted out because the ATP on the myosin heads are broken down into ADP and phosphate, which allows it to attach to the actin. Once it's attached to the actin, it releases the ADP and phosphate, and the myosin heads begin to bend and pull the actin along the myosin, known as the walking motion.
Acetylcholine esterase breaks down the acetylcholine in the synaptic cleft and in the ligand-gated sodium channels. The sodium in the T tubules then leaves since the acetylcholine is gone. Calcium attached to the troponin returns back to the sarcoplasmic reticulum, which is now more negative since sodium has left. Once calcium leaves the tropomyosin shifts back into place, which causes the myosin to detach from the actin and walk back and allow the sarcomere to relax back to a normal length. There's no more overlapping. This motion is acted out because ATP binds to the myosin heads, which breaks the bond between the actin and the myosin, which is the walking back motion. The I band is the area between myosin filaments where only actin filaments are present. The A band is where the myosin filaments are, and the actin may overlap here. The M line is the protein that the myosin is connected to, so it would be right in the middle. The H zone is the area that surrounds the M line, where only the myosin is present and actin can't reach. The Z disc is the protein where the actin filaments are connected to, and the sarcomere is the area that is between two Z discs.